At the heart of everything we do at Los Alamos National Laboratory is science. Pure and simple. Well, maybe not so simple. The diversity of scientific endeavor at Los Alamos is amazing. National security science requires basic research.
We have experts here from all over the world, and we also collaborate globally. This diversity of scientific thought has always been the laboratory's greatest strength.
The Manhattan Project brought together a large number of experts in various technical fields from all around the world to solve a very complex problem. Today, we rely even more on that level of expertise for certifying the safety of the nation's nuclear stockpile through very complex simulations on some of the world's most powerful supercomputers.
Computational simulations are vital to the work that we do here at the laboratory. There are many things that we're interested in that we can't actually test with a physical experiment. We need to use the best science and engineering that we have to protect the nation.
We're trying to solve problems through the pursuit of science with the hope that our science makes the world a better place. More than that, we can make it a brighter, a safer, a more stable place.
A national lab is always thinking about the biggest challenges that we have and how we come about solving those challenges.
Science here at Los Alamos is definitely not a one-person venture.
The collaborative nature of Los Alamos allows for experts in all fields of science to come together to solve big problems.
Problems that are too big for one person working in isolation to solve.
There's a lot of really good science here for a variety of global security, national security interests, because that's what needs to be done.
We like to leverage our science capabilities to inform our national security work, and then at the same time that national security work bolsters our science capability.
And because of that, we're able to work on new discoveries and different science that can't be done anywhere else.
Science is the ultimate exploration for knowledge. It's the way that we understand how the world around us works.
Science is curiosity, asking questions, developing solutions, so that we can actually have answers to mankind's biggest and most pressing problems.
The ability to work on complex problems, help solve them in the national interest, is one of the most rewarding things a scientist could ask for.
Our science is what prepares us to face the uncertainties of tomorrow. It allows us to achieve things that are right now only in people's dreams.
Welcome to the 14th Los Alamos ScienceFest. I'm Thom Mason, the 12th Director of Los Alamos National Laboratory. We were born as part of the Manhattan Project, building a bomb to end the war. Since then, we've been applying the best science and engineering to the most pressing national security problems our nation faces. We have employees on teams that study biology, space science, ensure safe operations, nuclear security, and so many things in between. We also place a big emphasis on pure scientific research, not specific inventions, just improving our understanding of the world, secure in the knowledge that that improved understanding is going to give us new tools and new ways of solving problems. My background is in condensed matter physics. It's the study of materials, the materials around us that make the world tick. You know, we characterize the ages of civilization in terms of the materials they control, the Stone Age, the Bronze Age, the Iron Age, now the Silicon Age. And of course, a society's ability to understand and manipulate materials has a direct correlation on its economic strength and its military might. So although it's a very fundamental science with all of the beauty of complex interactions, it's something that's not too far away from people's daily lives and the world around us. One aspect of the world around us that's been very much in everyone's thinking over the course of the last year is COVID-19. I'm as glad as you are to see the light at the end of the tunnel for the current pandemic. Now that many of us are vaccinated, it's wonderful to get out and start interacting with people again and the creativity that you can only experience face to face. The lab has had a big year in terms of helping in the fight against COVID-19. We used our facilities, our supercomputers, and expertise to study the disease. We have an infectious diseases modeling group that's been working since the 70s to understand really some of the national security and societal impacts of infectious diseases. And they've been making big contributions to policymakers in New Mexico and the nation. We've researched vaccines using our expertise in computer simulations to model how the pandemic might grow and evolve over time, trying to chase the origin of the virus, and study the effectiveness of mitigation strategies from the county level all the way to the global level. Our models are being used by some state governments and are cited by the CDC. It's a very busy time to be a scientist at a national lab in this area. There are 13,000 employees at LANL, so we have a lot of people working on many areas of important science. Our employees have created equipment for NASA. Most recently, you've seen this with the Mars rover. The power supply was manufactured using plutonium-238, which is work that we can only do at our PF4 facility. Even more exciting, the supercam that's being used to zap the rocks and understand the geology and chemistry of the Martian surface and the evolution of water over time is now actively being exploited, growing our understanding, building on what we learned with its predecessor, the ChemCam, that has been on the surface of Mars for the last 10 years. Of course, the reason that ChemCam's been able to drive around 10 years goes back to that plutonium-238 power source. We've designed parts for satellites. We produce medical isotopes that are in short supply. Using our Lance accelerator, the proton accelerator, we can make medical isotopes that are often short-lived. You can't stockpile them, and it means that you can't slow down even when there's a pandemic because the supply will be deleted. I'd like to give you just a few quick examples of some of the really groundbreaking science that we've been doing. We're working on a generator system that targets large radiation doses directly to cancer cells. This is a way of taking radioisotopes that we produce at our Lance facility and then couple them with chemicals that will cause them to attach to a cancer cell and deliver really damaging doses of radiation to the cancer cell, but leave the surrounding tissue unaffected and undamaged. We've been modeling trauma and predicting life-threatening brain injuries using the same kind of modeling and simulation tools that help us certify the safety, security, and reliability of the nuclear stockpile. We've been working with a class of materials called perovskites to create a low-cost process to more efficiently create power from sunlight. We're working on a technology to make biofuels more affordable. And we've developed novel instrumentation that better predict fire's impact on air quality and climate. This is an area that's going to become even more challenging given the changes in our climate and the increasing prevalence of large-scale wildfires. We're a world leader in the development of software to model changes in sea ice, how that's driven by changes in climate and in turn feeds back and affects the climate. We've developed a mini sensor for detecting toxins, bacterial and viral signatures, biothreats, and more. Los Alamos National Lab was created as part of the Manhattan Project to build a bomb to end the war. Nuclear security is still a big part of what we do, but if you step back, our real role is to bring the best science and technology to bear on the most pressing national security problems. We're a hedge against future uncertainty. Our role is to understand and develop solutions to future problems. And these occur in many areas beyond the traditional nuclear deterrence arena that we're so famous for. And before things like COVID-19 was even a known threat, national laboratories like Los Alamos were planning to combat known and emerging issues, not just in the area of biosecurity, but creating new ways to protect electric grids through quantum cryptography. We've seen how important this is with the attacks on high-profile companies like Colonial Pipeline. We're now teaching a new generation how to maintain the nuclear stockpile. Modernizing the U.S. nuclear posture is an ongoing challenge that requires bright minds and cutting-edge technology. Our nuclear experts are collecting and safeguarding unused or unguarded nuclear radiological materials to prevent dirty bombs. We're also researching pressing topics like climate change. Our research uses our supercomputers to develop global climate models, drawing on things like the sea ice model that I talked about earlier, and also to provide disaster response planning for extreme weather. National labs are known for developing cutting-edge science and technology, but unlike a company, Los Alamos does not commercialize its discoveries. We don't make and sell things to the public. We use tech transfer to work with companies who do, to give them technology that makes them more competitive in the marketplace, cheaper, better, faster. In that way, society at large benefits from those public investments in our research capabilities. But it's more than just the licensing of inventions. If you look at some of the startups that have been associated with Los Alamos, companies like Viome, Pebble Labs, Descartes Labs, and Ubiquity, it's as much about people who flow through the labs as it is about ideas. At LANL, we're doing a lot of work to connect with northern New Mexico, the communities in which we live and where we're located. In order to succeed, we know we have to actively invest in the region. A big priority is building relationships with regional colleges and K-12 educational systems to support our pipeline, make sure we have the skilled workforce that we need for the future. We know that close collaboration between employers, education leaders, state and local authorities is an effective way to create solutions that work for everyone. Educational partnerships provide skills development for the current laboratory employees and help us attract a next generation workforce. Through these relationships, we've created several workforce pipeline partnerships in the past few years. There's a new Associate of Applied Science in Radiation Protection at Northern New Mexico College. It's a program that provides us with radiation control technician pipeline that helps solve one of our most pressing critical skills needs. An Associate of Applied Science in Engineering Machining Technologies at Santa Fe Community College aligns its curriculum with the National Institute for Metalworking Skills and Laboratory Skill Set needs. With Taos and Cuesta High School, in partnership with the New Mexico Building and Construction Trades Council, we've developed a program that will give students the opportunity to apprentice in the skilled trades and help ensure that we build and maintain the cutting-edge facilities that we need to do our work. And there's a new Bachelor of Science in Mechanical Engineering at the University of New Mexico using the resources of both the main campus in Albuquerque and the Los Alamos branch campus. That's the final example of just a few programs, and I think we're going to need many more in the coming years. If you look at the makeup of the laboratory population last year, a little over 40% were from New Mexico. If you look at our new hires last year, it was over 3/4 who came from New Mexico. This is due in part to the success we've had in developing these regional partnership programs so that we have a pipeline of graduates who have the skills that are needed to work at the lab, enjoy good wages, good jobs that are making important contributions to our national security. I look forward to continued success in this area as we build out more partnership programs and draw on the increasing capabilities of the workforce regionally. At Los Alamos National Laboratory, we're all about solving the nation's most pressing national security problems through excellence in nuclear security, science, technology, and engineering, in operations, and in community relations. Behind that is a team of people whose creativity and commitment to our mission allows us to tackle those really tough problems.